So anyone that moves beyond the most simplest of home setup, a PC and a connection to the internet, is going to look at network attached storage. In fact, here at Gary Explains, network attached storage is the backbone of everything I do, because there's no way I can keep all of these video files that run into gigabytes, just on my PC. So I have 3 NAS units that I use for storing them, for backup and things like that. Now, today I'm going to talk about the TerraMaster F4-425 Plus, which is not only a great network attached storage unit, it's also very interesting as a home server. So if you want to find out more, please let me explain. So why do I say the F4-425 Plus is a great NAS unit and a good candidate for a home server? Well, there are 4 reasons for that. First is the processor. It's got the Intel N150 CPU in it, which is actually a CPU that a lot of people gravitate towards for their home servers because of the performance, but also because of its power usage. You've also got 16 gigabytes of RAM, which makes it ideal not only for running it as a NAS, running extra services on there, but also things like virtual machines and Docker. You've got plenty to play with. There are also 2 5 gigabit Ethernet ports, and then you've also got great flexibility when it comes to storage. You can add in hard drives and NVMe drives. So you really have got so many different options here. That means not just using it as a network attached storage, you can use it as a home server to run other services in your setup. Now I'm going to touch on each of those different things as we go along, but let's start with the storage because it is a network attached storage unit. So you can add 4 hard drives and 3 NVMe drives. Now, starting with the hard drives, they're very easy to add. There's these trays that slide out of the front. No screwdriver needed, no screws, no bolts, nothing like that. They easily pop out. You can put the hard drives in, again, all clips and plastic, sturdy plastic, no need to put screws in. You can get drives in there very simply, put them in. You can swap them if you get a drive failure very simply. So hard drives are really accessible and very easy to install in this set. And of course, with 4 of them, that gives you different options for how you're going to split up your storage into RAID and having failover drives. In fact, with T-RAID Plus, as we'll mention later, you can actually cope with up to 2 drive failures on the hard drive front. So that's absolutely brilliant. And then when it comes to the NVMe drive, a little more tricky, but not too tricky. You have to undo the case, unscrew 4 screws, pop the cover off the unit, and then you'll see the motherboard where there are 3 NVMe slots, M2 slot. You slot in your drives, screw them down, and you're away to go. Now, they are a little less accessible than the hard drives, but hopefully you won't have to be swapping them in and out too often. So you get the combination of hard drives and NVMe drives. Talking of the NVMe drives, one of the things you can do with this NAS unit is use the NVMe drives as a kind of cache for the hard drives, and I'm going to look at that in a separate video to see what are the pros and cons of doing that. Okay, once you've got your disks installed inside of your TerraMaster NAS, you need to power it up obviously and then connect to it for the initial initialization. Now, there are 2 ways to find it. You can just type in tnas.local into your web browser. That should pick it up. If it doesn't find it, there's actually a desktop app that you can download for Windows and for Mac that searches your LAN for your network attached storage and then finds you the address, and then you can open it up from there. Once you have access to the web interface, then basically you just need to start the process of initialization. So initialization basically means you install the OS. There's going to be a confirmation on which disks are going to be used as the system disks. And then after a reboot, there is just the license to agree to. Now you need to configure the name of your device and your initial username and password, remembering that you are the administrator using this username and password. So I'm going to create an account called Gary with my go-to password for stuff here in my house on my LAN. Now it also asks you to verify your email, and the reason for that is that it will actually contact you when there are major events happening on your NAS. So for example, here is an email I got when a synchronization had completed, and I don't have to therefore just keep looking at my web interface to see where it's happening. I get an email saying, oh, it's completed, and then I know the status of my device. Now for a quick tour along the top here, you've got a start button that allows you to shut down your NAS, reboot it, log out and so on. You've also got a place where you can access all of your applications. There's a dedicated space for all the backup tools that you need. There's the control panel where you can create users, change things with the networking and so on. And then over here on the right, there are some useful tools, including tools that allow you to see the current CPU usage and the memory usage and so on. Now, if you've been following the automatic creation, then you're going to get the storage pool automatically created for you. It's going to create that and then synchronize it. Remember, we've got redundancy here. So you've got multiple disks covering all of the data. Now, if you do choose to do things manually, then you will get to select different disks that you want in whichever pool, in whichever volume you want. And there are different methods here. There's T-RAID, T-RAID Plus, and then RAID 0, RAID 1, RAID 5. And this handy little tool shows you how much free space you're going to get with that combination of disks, how much redundancy there is, and how much wasted space, because sometimes various combinations of different sizes of disks can mean there's just some space left over that can't be used. Remember, the difference in T-RAID and T-RAID Plus is that T-RAID can cope with the failure of one drive and T-RAID Plus can cope with the failure of two drives. Now, it's worth mentioning that Windows networking is enabled by default. So if we go here to the control panel and then to file service, we can see SMB, Samba you might call it if you're used to the Linux side, is already enabled. You're in the work group, and the home directories are automatically shared. So if I now go to Windows Explorer, so you can see here // TNAS425, which is the name that I've given my NAS, / Gary, because I'm a user on this NAS, and it's given me my home directory. And as you can see here, this is Gary's home folder.txt. Now, if we go to the File Explorer here on the actual interface, here I am in my home directory. So this is Gary's home folder. So there you go. Everything that is in my home folder on here is automatically shared. And if you create other users, they would also be shared too. The bottom line is it's really easy to get up and running with this because everything you need is enabled and you're able just to connect to it, log in, and there's all your data. Okay, so let's talk a bit about the networking on this device. The TerraMaster F4-425 Plus has two 5 gigabit Ethernet LAN ports, which can be used obviously just on their own, or they can be used together with link aggregation. For example, there is an adaptive load balancing mode. There is the IEEE 8023AD link aggregation. You need a switch that can work with that. There's balanced XOR mode, which basically looks at the MAC address, does some mathematics with XOR, and then it basically decides which port it's going to use. So therefore you get balancing across both ports with a random sampling of all the different MAC address clients that will be connecting to it. And there's of course failover backup. Now for my testing, including the performance testing, this is kind of my setup. We have the TerraMaster NAS here. I have a network switch, and of course I have my PC. Now the TerraMaster has two 5 gigabit Ethernet ports, as we've already discussed. I'm using one of them. Now my rest of my network, my switch is 2.5 gigabits and my PC is 2.5 gigabits. So basically I'm connecting a 5 gigabit Ethernet device to a 2.5 gigabit Ethernet network. That means that for me, when I'm copying files to and from this NAS, I'm going to only reach 2.5 gigabits as the theoretical maximum bandwidth because I don't have anything more. Now, what disks am I using for my performance testing? Well, I'm using a combination of both hard drives and SSDs. So for the hard drive, I've got four 7200 RPM 3.5 inch SATA drives using T-RAID. And so there are two 1 terabyte drives and two 500 megabyte drives. They're combined together with T-RAID. That will improve both read and write performance because it can read and write from 4 drives at the same time in parallel, which improves the overall performance. And I'm also using two NVMe drives. Those are Lexar NM620 drives, 256 gigabytes each, again using T-RAID, so they are combined together, so both devices are used for reading and for writing. And in all of these cases, it supports up to 1 drive failure. So if a hard drive fails, the volume there will survive, and if one of the SSD drives fail, then the data is still intact. So what kind of performance numbers am I getting? Well, I've done several different tests, and again, remember here that I've got that limit on the 2.5 gigabit Ethernet. So if I copy a 10 gigabyte file from the hard drives, that's the 4 hard drives on the NAS, to the SSD on my PC, I get 280 megabytes a second. So basically that's maxed out on the 2.5 gigabit Ethernet that I've got here. And if I copy them from the SSD volumes, those 2 drives together in T-RAID, I get the same 280 megabytes a second. So basically I can saturate my network, my 2.5 gigabit Ethernet network, completely when copying large files. Now, if I copy smaller files, I've got a directory with 10,000 files in it, different sizes from 1K up to 10 megabytes, a total of 49 gigabytes in total. If I've got that on the hard drives, those 4 hard drives, and I copy it over to the SSD on my PC, I'm getting about 180 megabytes per second. Now, some things to notice here: small files are always harder for an OS to copy because it doesn't get a much chance to just start saying read the next chunk, read the next chunk, read the next chunk. It's got to start dancing around a little bit. And also I don't know what that means for the write performance for my SSD as well. So there is not saturated here on my 2.5 gigabit Ethernet network, but it's hard to tell exactly where that bottleneck is. And interestingly enough, if you do the same thing with the SSDs, I get a slightly lower speed, this time 170 megabytes a second. That could just be those Lexars are not quite as good at random reads as they are at sequential reads. Again, since you've got several different components in the chain here, you've got my SSD on my PC, got the SSDs in the NAS, you've got the NAS itself, you've got the network. It is hard to nail down exactly where the bottleneck is. However, for copying small files, I think that's a pretty good result. And finally, I did an internal test so you can get access to a file manager via the web browser. In fact, I did this via the terminal. So I copied a 10 gigabyte file from the hard disk volume, so there's 4 hard drives, to the SSDs internally. So it's not going out to the network. This is just an internal copy. And I was getting 222 megabytes a second. And then if I do it the other way, I go from the SSD drive to the hard drives, then that goes up to 292 megabytes a second. Okay, so now I want to talk about the hardware transcoding that you get because it's this Intel N150 CPU. So here I've installed Jellyfin on the TerraMaster NAS, and here I've got some films in the media library. Now if you just click on a normal film here and start playing it, let's just skip forward here a bit. There we go. Now you can go down here and you can get the playback info, and we can see here that the film is actually encoded in H.264 and it's just playing it directly. So no transcoding going on here, just playing it back directly, and that's absolutely what you would expect. I've also got a 4K demo movie here that I downloaded from the internet from Hisense, just a demo video that shows 4K, I think, for their televisions. So here is 4K playing back, and that's important. This handles 4K playback without any problem. If we go down here again to that same playback info, we can see that it's encoded in H.264 and it's just playing it back directly. However, what we can do is we can go down to here and go to the playback quality, and we can drop it down to something lower than what is the actual encoded quality. So I've dropped it down to 15 megabits per second. And now when we go back to the playback info, we can see that because the video's bitrate exceeds the limit, because it's too much, it's having to transcode it. So here you can see it's transcoding, and you can see it's transcoding here at 60 to 80 frames per second. So to bring out the new bandwidth, it transcoding it from H.264 to H.264, but reducing the bandwidth on the way, and it's doing it at more than the playback speed. So here we're currently at 63 frames a second. We were up at 70, 80 frames a second. And you can see that the transcoding progress is going on in the background as it transcodes the whole thing. So hardware transcoding on a 4K video is working absolutely fine. Now let's also look at the CPU usage while it's doing this. So here we are back on the administration interface, and you can see here CPU load is very, very small because it's doing it in the hardware of the chip, so the video decoder, encoder, the GPU, that side of things. It's not doing it because in the software and CPU. So the CPU is very, very low, even though it's doing 4K transcoding. Now, another example is here. If we just look on this one before we start playing it, media info, we can actually see that it's an MPEG-2 video. So quite an older standard. MPEG-2, of course, is what we had on the original video CDs, used a lot in digital television satellite broadcasting. Things have obviously moved on since then, but MPEG-2, now this system won't play MPEG-2 natively, so it's going to need to be transcoded on the fly into something like H.264, and let's see what it picks. So let's go ahead and click the play button there. Again, we'll just skip forward to get something actually going on. This is bad quality because of the source, not because of the transcoding. Okay, so we're going to go down here now to playback info, and we can see again it's actually transcoding on the fly from MPEG-2 to H.264. Look at this, 823 frames a second. I mean, it's just 600 frames. I mean, it's just doing way, way more, 10 times faster than what you need, 20 times faster than what's the original source. And again, that's the hardware transcoding working. Again, the quality because of the source, not because of the transcoding. Now, the advantage of having 16 gigs of RAM is that you have enough space to be able to run virtual machines and Docker containers without actually impacting on the performance of your NAS. In fact, I'm going to do a separate video about the RAM sizes of a NAS like this TerraMaster and the ability to run other virtual machines, containers and so on, and then see what impact it has on the overall performance. So that would be quite an interesting experiment to see if you've got 16 gigs, you know, and you're using up 12 or 14 gigs of it, you know, using containers and virtual machines, does that impact on the performance? So stay tuned for that video. But to install a VM, you need to go to the App Center and then install VirtualBox. VirtualBox, of course, is a very popular open source hypervisor, and you can install it here on the NAS, and then you're going to use it via a web interface because obviously we're not running on a popular desktop operating system here, so we can use it using a web interface. The first time you log in, the username and password are admin and admin, so that's quite easy to remember. Now, to create a virtual machine, you click on the new icon and then you basically go through the setup here. I won't go into too much detail, but basically you're creating a virtual machine. You're going to set the amount of memory you want. You're going to set the size of the virtual hard drive, which gets created on the NAS, of course. And then you're going to want to say which ISO file you want to boot from. I've got the ISO file already downloaded onto the NAS, and once that's booted, you gain access to your running virtual machine via the remote desktop protocol, and you can either type in the numbers that VirtualBox shows you, or in fact you can download a config file which you can then double click to actually get straight into your virtual machine. So here we are on the Debian desktop. It's all installed perfectly well, and you know, you can start the application and just use it like you would any virtual machine really. But this isn't running on your local PC, it's not running anywhere else, it's running on your NAS, which really in this case has now become really the perfect server for a home lab, a home network with, you know, storage and containers and virtual machines and so much else, you know, Plex, Jellyfish, and so much other stuff that you can do all from one box. And so there you have it, the TerraMaster F4-425 Plus. Not only is it a great network attached storage unit with that flexibility of hard drives and solid state drives with NVMe 2 slots there, you've also got enough CPU power and enough RAM that you can actually expand on this to cover virtual machines and other network services all within one unit, which is just a great idea. Love to know your thoughts on this unit in the comments below. Do you use NAS? Is this the kind of NAS that you would be interested in getting if you were to purchase one? Love to hear your thoughts. Okay, that's it. My name's Gary Sims. This is Gary Explains. Hope you enjoyed the video. If you did, thumbs up and don't forget to subscribe. Okay, I'll see you in the next one.